Have you ever wondered why the sun, a blazing ball of fire, has dark spots? Or why it occasionally throws out a burst of radiant energy? It's as if the sun, the very symbol of light and warmth, holds within it a world of contradictions. These peculiarities that we observe are commonly known as sunspots and solar flares. Sunspots, contrary to their fiery surroundings, are cooler, darker areas on the sun's surface. They appear as blemishes marring the otherwise radiant face of our sun. On the other hand, solar flares are sudden, dramatic explosions of energy, much like a cosmic firework display. Both these phenomena, as common as they are, remain a subject of intrigue and exploration. The sun's surface, it seems, is a bustling hub of activity, with sunspots and solar flares playing their parts in the celestial drama. These cosmic phenomena are not as random as they seem, but are deeply interconnected and play a vital role in our understanding of the sun. Sunspots, despite their misleading name, are not spots on the sun, but vast regions that are cooler than the surrounding areas. Let's dive into the science behind these intriguing phenomena. Sunspots form due to the sun's magnetic field. This magnetic field inhibits the flow of hot, luminous gas from the sun's interior to its surface. Think of the sun as a giant pot of boiling soup with bubbles of hot gas rising to the surface. Now imagine a lid. That's the magnetic field, stopping some of these bubbles from reaching the top. These lidded areas are the sunspots. Because hot gas can't reach their surface, they're cooler than the rest of the sun. And because they are cooler, they appear darker. But don't be fooled into thinking they're cold. A cool sunspot is still hotter than anything we can imagine here on Earth. So, sunspots are not defects, but rather fascinating byproducts of the sun's complex magnetic activity. Solar flares, on the other hand, are brilliant displays of the sun's power, releasing more energy than millions of nuclear explosions. These radiant spectacles are caused by a fascinating solar phenomenon. Imagine the sun's magnetic field lines getting tangled, crossing over each other, or undergoing a reorganization near sunspots. This creates a buildup of immense energy, which, when released, erupts into the spectacle we know as a solar flare. These solar flares are not just eye-catching displays. They release energy equivalent to billions of atomic bombs in a matter of minutes. This energy, in the form of radiation and high-energy particles, can reach as far as our planet. While our atmosphere and magnetic field protect us from most of these effects, intense solar flares can disrupt satellite communications and power grids. Solar flares, while a spectacular sight, remind us of the immense energy and activity constantly taking place on our sun. Sunspots and solar flares are not isolated phenomena, but two sides of the same coin, both resulting from the sun's magnetic activity. Let's take a moment to recap. Sunspots, those dark patches on the sun's surface, are cooler areas teeming with magnetic activity. On the flip side, solar flares are sudden, explosive releases of energy, sparked by the reorganization or tangling of these magnetic field lines near sunspots. These phenomena are not just fascinating spectacles. They are integral to our understanding of the sun's magnetic field and its cyclical patterns. Their study helps us unlock secrets about our closest star. Moreover, their potential effects on Earth can't be overlooked. Solar flares, for instance, can disrupt satellite communications and power grids, reminding us that we are not isolated from the cosmic happenings. So the next time you look at the sun, remember, it's not just a bright ball in the sky, but a dynamic and complex celestial body full of mysteries waiting to be unraveled.